All right, ready for the first one. All these are in polar. They're not going to say any more x's and y's. First one I want you to try to graph with me is r equals 5. What does that graph look like on the polar graph? Well, ready? Anybody remember what the r value meant? What's it mean? The r value, 5. Distance from the center. It does not matter what the angle measurement is. The distance from the center will always be 5. So ready? If I'm at 0, what's the distance from the center? 5. So everyone go 5 units out. So 1, 2, 3, 4, 5. What is it at pi over 12? Still 5 units away. Do you see what's going to end up happening here? At pi over 6, what do you have? Still 5 units away. What am I going to end up forming here as I go all the way around? Okay, there we go. So this right here, r equals 5, will be a circle. That's 5 that has a radius of 5. And then you can graph that if you want to do all the points, sure. If not, just make sure you got a nice dark line. If you want to grab a colored pencil, you can. But that is r equals 5 on the polar graph. For all the angle values, it's always 5 units away. Everyone all good there? Any issues? All right, what if I change it to a negative now? I'll let you guys finish graph. R equals 5. Big circle around. R equals -3. Ready? So at 0, I'm going to go 3 units. But anybody remember if the R value is negative, what do I do? You go opposite, right? Okay, so if I'm at 0, I go opposite and still go 1, 2, 3. And start thinking about what's going to happen here. If I'm at pi over 12, I go 3 in the opposite direction. Oh, sorry, right there. Guys, what's going to keep happening here? I'm going to make another. Did I count wrong, Matt?
No. So it's just 3 then?
Still 3. R equals 3 and R equals -3 will still be a circle with 3 units away. Yep. I just wanted to remind you guys that you're going in the opposite direction when the R value is negative. All right.
How do you label it? Or do you not label it?
You don't need to. As long as you have just one graph on each one, that's fine. We're never going to do 2 on 1, so you don't have to worry about labeling it. Everyone all right? Because now we're done with these. Okay, a little bit different now. I got R equals 4 cosine theta. So not as easy as a number. Got your calculator ready. Everyone's got a calc in front of them. Because we're going to have to plug in values here. Look at, hey, first of all, before we do anything, look at your theta values. They're all in what type of measurement? Radians. So probably a good idea to do what before we get started? Change your mode into radians. All right, change your mode into radians. So I'm going to give you the angle measure as we go around. You're going to plug it in for theta and tell me the R value. So the first number we're going to plug in is 0. So you're going to do 4 cosine 0. And tell me what R value you get out. 4 cosine 0. What do you end up with? 4. So my first point will be, what was your R value you just got out? 4. And what angle did you just plug in? 0. So our first point, would you guys rather just list them all or graph them as we go? List them, then graph them? Okay, that's fine. Your preference. So 4 zeros our first point. All right, what about pi over 6? So now I'm going to go 4 cosine, and now you guys are going to do pi divided by 6. And as long as you're in radians, 4 cosine pi divided by 6, you should get this decimal. Just make sure we're all on the same page. Let's go. 3.46410. We're all good? All right, I don't want to write all that so we can round to the nearest 10. So about 3.5. So my coordinate's going to be, what was your R value? What did we just round to? 3.5, comma, what angle did you just plug in? Pi over 6. Everyone see how we're going to come up with points for this graph? Okay, if you guys want to get ahead of me, you can. If you want to keep staying with me, go ahead. So now I'm going to do 4 cosine pi over 3. You plug in the angle, you get the R value back out. This R value should be a whole number. What do you have? Whole number here? 2. So next point, 2 pi over 3. All right, go ahead. See if you can keep doing it on your own, round to the nearest tenth if necessary. And then we'll talk about graphing them. And hopefully you start seeing a little repetition. That's great that you can copy it off the board. Better be able to get it from the calculator. And just let's make sure we compare, because, hey, I might have gotten one incorrect. You never know. Won't be the first time. All good? You ready to plot them? Everyone ready to plot? Okay, first point, 4, 0. So at 0, how many units are going to go out? 4. So everyone go 4 units out. I'm going to take my time here. This is the only one we're doing today. 1, 2, 3, 4. There's my first point of the graph. Now we're at pi over 6. Pi over 6, we're going to go how many units out? About 3.5. You can estimate it, about 3.5. So my eyes kill me here. 1, 2, 3.5. 2 pi over 3. So at pi over 3, go out 2. Zero pi over 2. So where should you graph this one? Right at the where for 0 pi over 2. Yeah, you're not going anywhere. Right at the origin. And as you guys start graphing a couple of them here, start connecting them so you know what order you did them in. Okay, ready? -2, 2 pi over 3. Ready? 2 pi over 3, but it's -2. -2, help. On the other side of 2 pi over 3, right? So I don't want to graph 2 from 2 pi. Now, I don't want to graph this point here. I want to go on the other side and graph 2 from there. So where am I here? 1, 2, 1. At 5 pi over 3, I actually want to graph 2. Everyone see that with the negative. Negative 3.5, 5 pi over 6. So here's 5 pi over 6. Go the opposite side. So I should be at 11 pi over 6, graphing 3.5. That's 2. That was 3.5. And then guess what starts to happen now? Negative 4 pi. Oh, here's pi, but negative 4 tells me opposite side. What have I already done? I already graphed that point at the beginning, right? I already graphed that point. All right, what about negative 3.5, 7 pi over 6? Already graphed that point. Okay, already graphed that point because it's on the opposite side. Everyone's starting to see it's going to repeat. Repeat, 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 repeat. Let's finish this up. Hexagon. It's a circle. Okay, we'll get over that. We'll get over that, hopefully. Okay, hold on. Okay, hold on. This is why the old Chromebook comes in handy here in a second. Questions there before we check it? I'm going to have you guys check it. I gotta, because as you started to see here, we think this is a hexagon. All right? Stop talking. All right? Okay, so open up the Chromebooks, open up a browser for me. I'm going to show you a site where you can go, pretty powerful site that will graph these for you. This is and this is solely for a check. Every problem, I'm going to need to see the table of values. This is solely for a check. This isn't you go to this site and just throw on the graph what it looks like. All right, this is solely for a check. Okay, well, we'll see. Yep, great minds think alike. There you go. Yep. Okay, everyone ready? I need my typing too. Desmos.com, DESMOS.com. It is a graphing site, which, and I'll tell you what, this is pretty more powerful than your graphing calculators, but we're not allowed to use it on the region, so we don't say anything. All right, everyone ready? Start graphing. Just everyone's got this graph right here. Yeah, this is a rectangular graph. So how do I change it to a polar? Everyone see the wrench right up here? Top right-hand corner of your screen, there's a wrench. Click on it. Everyone see right here, it says grid. And see how the rectangular one's highlighted? Highlight the polar. Boom, look at that. Okay, so again, wrench, highlight the polar graph. Now over here, right over here is where you're going to start typing in your equations you want to check. Okay, so I'll do this with somebody slowly. What was the equation we just graphed? Okay, everyone ready? R, so hit your R. Everyone knows where your equals is. R equals, what was it? Okay, so 4 cosine. Now here's how you got to do theta. Ready? You put your parenthesis, and then you actually type in the word theta, Theta, and then the symbol will come up. Pretty clever, huh? And look at that hexagon that was graphed, huh? Theta. So this is where we can go now to start checking our graphs, because they're going to get a lot more involved than a circle. We're going to get some hearts. We're going to get some leaves later on down the road, and you want to make sure you did this right. All right, before we leave, though, I just want to do a little playing around here. What do you think if we change the cosine to sine? Go ahead. If we change cosine to sine, where does it end up? Okay, now let's talk about this. Anybody have a way to remember why cosine would end up on the x-axis and sine would end up on the y? Sine, we always plug in what? Y, and cosine, we always plug in x. Quickly, change the number now. Let's say I change it to 5. What do you think will happen? Hey, I change it to 5. What's going to happen? To 5. What if you think I make it negative? What do you think?
On the side, yeah.
Oh, you can do negatives.
Yeah, flip it over.
Sine 8 theta.
What?
Just do theta. Just do sine 8 theta.
8?
Yeah.
Yeah. Or 10 or whatever. Whoa, that's cool. Do sine 8. Do sine 8.
Just go
No,
theta.
just go theta. Just delete the
R
sine.
equals theta.
Hey.
Oh, you guys are nuts. You're nuts over there. I know. Look at playing around with this. We're actually, you guys that told me to go 8 there, that's what we're getting into. That's the last type of graph we're going to do.
You have like multiple equations then?
Yeah, go down, just press enter.
Can you do a squared? Is that you square it?
Square what?
Cosine squared.
I'm sure you can. What R equals cosine. How do I do SQ? I don't see. See, I'm not too familiar with this. I don't know how to do a squared on here. But that's what we're getting into is those. If you'd like to know limaçons, impress your friends later right here. Limaçons that look like the Leafs. All right. So if you want to keep playing around with that today, go right ahead. But that's how I want you to check your graphs from now on. All right, starting tomorrow on the classwork. All right, that's all I got for you.
Okay.